We're looking at number 5. Number 5 says points A, B, and C are collinear. And it's saying that point B lies on top of line segment AC, such that we have a ratio when A is to B, it's 1 to 2. So what that's saying is AB is going to be half the size of BC. So this is our A, this is our B. If we want a ratio, it would be equal to A over A plus B. So our ratio is going to be 1 over 1 plus 2, which is equal to 1/3. So our ratio is 1/3 here. Just keep that in mind. I don't know if we need it. So given A and B have coordinates 4, 6, and -2, 9. So here I do suggest that we use the graph given on the EOC. Doesn't have to be perfect, but try to do your best to keep it aligned. So what I'm going to do is draw a rough sketch like I would on the EOC. Okay, we're given the points A and B. So A is at 4, 6. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. So A is at 4, 6. Okay. So then here we have B. They gave us B, which is at -2, 9. 1, 2. 1, 2, 3, 4, 5, 6, 7, 8, 9. So point B is right there. -2, 9. Well, it's saying point B lies on AC. So B is the middle. So we're looking for point C. We're looking for point C. Point B. So we need to use this ratio they gave us. So they're saying A to B is 1, is half. A to B is half, because right here the ratio is there's 3 sections. So this is half the size of BC. And since B is the, not middle point, you could say it's like the 3rd point, but it's like the stopping point. So C, using this logic, needs to be in this direction, since it's a line. It's going linearly. So the way I would apply this problem is I would use slope. So if I use slope here, I'm going to count the distance going up. So when we're doing slope, we're focusing on the right here, we're focusing on that. So the difference between, if we use the ruler postulate, the difference between 6 minus 9, absolute value, -3, or after that's broken, we get equal, we get a distance of 3. So it looks like here we have a rise of 3. Now let's focus on the x's. Okay, so if we're focused on the x's, it's going to be going from here. So it's going from 4 to -2. We can do the ruler postulate as well. D is equal to, what is D equal to? The absolute value of 4 minus -2, which we get absolute value of 6, which is equal to 6. So the distance between 4 and -2 is 6. So our slope here, don't simplify our slope here. I know it's a little convoluted right here, but our slope here, 3, rise 3, left 6. So we rise 3, we go to the left 6. So that means we're going to be using a slope If this is 1 times 3 over 6, that means our slope for BC is, remember, the length of BC, B to C, is 2 times AB. So if we're given a slope of 3 over negative 6, we're going to double that, and we get a slope of 6 over negative 12. So that means we're going to rise up 6. We're going to go left 12. So that means let's rise up 6 right now. We're at 9. So that means if we just use the point, we don't even have to touch it. If we rise up 6, that's a 9. We're going to go up 10, 11, 12, 13, 14, 15. So we just went up 6, and we're at point. We're at negative 2, 15. I know this is a lot of work going right here. That's why we should have it on the graph. And then from here, we're going left 12. So we're going negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10, negative 11, negative 12, negative 13, negative 14. Should be something like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So then now we're at negative 14, 15. If we continued that linearly. I could even try to use this marker to kind of gauge it. Not perfect, but point C is right there. Only answer that makes sense here would be A. And half the battle of this problem is knowing where C is, because if you went the other direction, you may have got one of these.